In today's note, we're going to be looking at key features of lines. So in our investigation of looking at different patterns, we've seen that we can get a straight line when we have a certain formula. And while we may have used other variables in the investigation, this is the key formula that we're going to be using, and it is y equals mx plus b. So this is going to be our key formula for any straight line. And our m value is known as the multiplier. You can think of m as multiplier, or you might hear it known as slope, rate of change. Right, so we may see it in those terms. And our b value in our investigation was kind of our constant. But more generally, it is our y-intercept. And y and x are values of any given point on the line. So if we had a straight line, y and x represent values of any given point. And if you remember from our last unit, we've talked about points being coordinates like x and y. And there are two key points on any line, and that is the the x-intercept and the y-intercept. So if you don't know what these terms are, the x-intercept is where the line crosses the x-axis. And a key thing about this is that the y value is 0. So you'll have a point that is always whatever the x value is, and then 0. And the y-intercept is very similar. It is where the line crosses the y-axis. And in this case, the x value is 0. So you may have a point that is 0 and then whatever the y value is. So those are two important points on any line. So if I were to look at this line and I have my given equation here, y equals 1/2 x plus 4, or my multiplier is 1/2, my constant is 4. If I want to find out where my x and y intercepts are, I just need to look for where the line crosses both the y-axis and the x-axis. So first one, let's go with our y-axis. So our y-axis is the vertical one, and we can see that it crosses here at this point. So this point would be my y-intercept. And this point, because it is at the coordinates of 0, 4, that would be my y-intercept. Another way I could figure that out, I do have an equation down here of a line, so that means that 4 is also my y-intercept. So again, that's where we can get it from just looking at the equation. The x value, or my x-intercept, I look along this horizontal line. Where does it cross here? Well, it crosses at this point here. And what are the coordinates for that point? Well, the coordinates at this point are -8 and 0, and this is my x-intercept. So for this line, my y-intercept is 0, 4, and my x-intercept is -8, 0. So if I want to find my x and y intercepts, I can do it in two ways. One, I can do it by graphing the line or by looking at my line, and the second way is by solving algebraically. So the first one, we're going to solve by looking at the graph. So I have in example A, I have my graph. I'm looking for where it crosses the two axes. So I have one here and one here. The first one here, this one's going to be my y-intercept because it is crossing the vertical line or my y-axis, and this point would be 0, -4. The x value is always 0. For here, for my x-intercept, it is going to be at the point 2, 0. You see we go over 2, we don't go up anything, and the y value is always 0. Good. My next example for B, again doing the same thing, looking for where my line crosses the axes. So the y-intercept, where it crosses the vertical one, and in this case it is 0, 1. The x-intercept, here it crosses at 3, 0, which is my x-intercept. So again, another key thing, if you're looking for the y-intercept, that means you're looking for a y value. If you're looking for the x-intercept, that means you're looking for the x value. And then the other missing values are just 0. In example C, C is a little different. I just have an equation. But we do know some key things from our equation. If we remember that our equation is in the form y equals mx plus b, where m is our slope and b is our y-intercept or constant. So that means that in my equation here, the b value is at -6. So that means my y-intercept is equal to 0, -6. Now, if I want to find my x-intercept, again, we know something important about our x-intercept, and that important thing is that the y value is always going to be 0. So if I know one part of my point, I can plug that into my equation. Choose a different color. So y equals 2x minus 6. I know that if I'm looking for my x-intercept, I know the y value is 0. So that can get plugged in for y. So 0 equals 2 times x minus 6. And now we're solving an equation. If I bring the -6 over, it becomes +6 equals 2x. 6 divided by 2, I get 3 equals x. So that means that this 3 value is my x-intercept. So my y-intercept for this equation would be 0, -6. My x-intercept would be 3, 0. If I look at example D, I'm going to do the same thing. I know I have the equation y equals mx plus b. Again, b is my y-intercept. M is my slope or multiplier. So that means from my equation, this +8 is considered my y-intercept. So my y-intercept, I can tell right away, is going to equal 0, 8. This time it's positive because we look at the sign in front. For my x-intercept, again, I know that the y value of my point is going to be 0, so I can use that for when I'm solving this equation. So y equals 2x, or sorry, that's the last one. Y equals 1 over 4 x plus 8. I'm going to plug 0 in for y, so 0 equals 1 over 4x plus 8. Move the 8 over, I get -8 equals x over 4. Because I want to move or get rid of this fraction, I'm going to multiply by the denominator. So I get -32 equals x. Yes. So that means that the value, or the x value of my x-intercept is -32. If I look at example E, E is similar, but it's still different. We're still using an equation, however, it's not in the form y equals mx plus b. So what we want to do first is rearrange. So let's get this into the form y equals mx plus b. In order to do that, I want to move this 3x over. So in order to do that, I'm going to subtract 3x. So that means I have 4y equals 12 minus 3x. And now if I want to get y by itself, because remember our general equation, y equals mx plus b, I need to divide both sides by 4. So y equals 12 divided by 4 is 3, minus 3x over 4. And now I have it into that equation, or that form, y equals mx plus b, albeit slightly rearranged, but it's still in that form. If we want to rearrange it to get to the actual form, y equals, and we'll just swap these, negative 3x over 4 plus 3. So that means now, based on this equation, my y-intercept is going to equal this last number. So now it is 0, 3. My x-intercept, we know part of it. And we know that part is that the y value is always going to be 0. So let's take that and plug it into our equation. So y equals negative 3 over 4x plus 3. Let's take that y and value of 0, substitute it in. So 0 equals negative 3 over 4x plus 3. If I want to move that 3 over, it becomes negative 3 equals negative 3 over 4x. If I want to get rid of that fraction, I'm going to multiply both sides by 4. So I get negative 12 equals negative 3x. And then if I'm dividing both sides by negative 3, I get 4 equals x. So that means then that my y value for the x value, for the x-intercept is 4. Same kind of steps in example F. I want to rearrange it to get it into the form y equals mx plus b. So in order to do that, I move the 6x over, so I get y equals negative 6x plus 9. Now I want to get rid of this negative 1, so I'm going to have to divide both sides by negative 1. Y equals 6x minus 9. And now I know my y-intercept. So my y-intercept is equal to 0, negative 9. In order to find the x-intercept, again, I know one value of it, and that is that the y value will be 0. So I can use that in my equation. So I have y equals 6x minus 9. I'm going to replace the y with 0. So 0 equals 6x minus 9. Bring the 9 over. Positive 9 equals 6x. Divide both sides by 6. I get 3 over 2 is equal to x after I simplify. So that means that my y-intercept, my x-intercept is 3 over 2. So again, the key things from this is just understanding that we have our general equation, y equals mx plus b, where m is our slope or multiplier, and b is our constant or y-intercept, and then understanding that the x-intercept is a special point where the y value is always 0. The y-intercept we can get from our equation, and it is also special because the x value is always 0 for the y-intercept. And then we should be able to find those values either algebraically, like we just did, or by looking at a graph.